All right, so our order of operations for today, we're going to look at two different approaches for how to add and subtract polynomials. Yes? Yeah, I got it. I know. We'll do it after the lesson. We're looking at two different approaches. We have just a couple examples, and then really with this, we're going to do a lot of practice.
Okay.
Is that fine? We have, all right, listen up, listen up, listen up. Okay, then flatten them. Like, yeah. Well, there's nobody in front of you that you're infecting, so we're good. So we have two different methods that we can use.
The one that we did not need to.
Yeah, I need to see. It is what it is. Please, they can see this.
Oh, God.
We're good. You good? You ready? Okay.
I'm ready.
We have two different methods that we can use to add or subtract polynomials. Okay. One of them, and the first one that is probably least popular, but if this makes sense to you and you like it a little bit better, is the vertical method. No. So with the vertical method, with this one that they're showing, they would have given you 3a squared plus 8. Okay? And they would have told you to add 5a minus 1. So that's probably how it would have started. Now what the vertical method says to do is to take your first term, put it on top, and then your first polynomial, put it on top, your second polynomial, put it on the bottom. Notice that you line up like terms. So they line up 8 and 1. Nothing is lined up here with 5a because this first polynomial doesn't have a term with just an a involved. Are we seeing that? How they line things up? How they line up our like terms? And then we're just adding like we would if it was a regular addition problem. So they call this the vertical method. So 8 minus 1 gives us 7. There's nothing that we're adding to 5a because there are no like terms that have a. So we stick with 5a. And then there's nothing with an a squared. So we stick with 3a squared. So just lining up the like terms just like a regular addition problem and adding straight down. The second one that's more popular would be over here, the horizontal method. And that is just, taking our initial problem and moving around like terms to group them together. So you can see our initial problem starts here, and then in the second line, they group together all the terms that have x squared, and then they group together each term with x. Notice they take the negative sign, I kind of drew over it, but they take the negative sign down here with 8x. And then lastly, they group together just the whole numbers. And that's probably, we might not call it the horizontal method, but that's probably the way that we are more familiar with. Of just lining them up, combining our like terms. So if we had a question like this, and if we were using the vertical method, we would line up our first one, line up our like terms, add them together, negative 10 minus 3 would be negative 13, and b plus 4b would give me 5b. If we were doing the horizontal method, we would rewrite this first as b plus 4b plus negative 10 negative 3. If we were doing the horizontal method, we would get the same thing. Now once we have, since it's addition in the middle, once we distribute anything that needs to be distributed, then we can drop the parentheses. So with the addition in the middle, there's nothing that we're really moving around. So we could write this just like this, without the parentheses. We can drop them, and then it makes it easier to see how we can move things around. Questions on that example? All right, subtracting polynomials. So this is where people tend to forget the negative a lot. So with the vertical method, same thing. You can see that they line up our two polynomials so that the like terms are all lined up there. Now, instead of going right to adding or subtracting, the first thing that they do is take this negative out front and they distribute it to each term in the polynomial. And that's how we get from here to over here. It's just distributing that negative. And that's where, like I said, sometimes people will distribute the negative to the first term in the polynomial, but then like they give it to the 2y squared, but they would forget to give it to the 5y and then to the 3. So we need to make sure that we distribute that negative to each number in our polynomial. That would be using the vertical method. In the horizontal method, down here, it'd be a very similar idea. We've got this negative sign in the middle. So the first thing that they do is distribute it to both the numbers in the parentheses. Technically, after we distribute it, we could drop the parentheses. So we could also, instead of writing it like this with the parentheses up, that's totally correct. But after we distribute that negative, we can drop the parentheses. We'll write it just like this. Because we took care of the negative. There's nothing that the parentheses are holding on to. If we drop the parentheses, we still would follow the same steps that they show. We still would group together like terms. Right, take that negative sign with our 2x squared. And that should be 4x. On the left is just 4x. And we have negative 1 plus 6. And that would simplify the same thing that they have. Is this something that you guys have seen before? How about adding and subtracting like terms where there's like 5x squared minus 2x squared? Have we seen that before? Okay, so this isn't anything that's too far to reach. Questions on that? So if we look at this example with subtracting, what I would do when I'm solving these is I would just distribute that negative and drop my parentheses. So that negative needs to go to each term. So instead of writing next negative 4p squared, take the opposite, take the opposite, take the opposite. Now my parentheses are gone. I can combine like or rearrange with the like terms. So I have p squared, 4p squared, p. Plus 3 minus 3. 5p squared. And then plus 3 minus 3 would be 0. So you can simplify that all the way down. Questions on that before we move on? So that is, those two things, adding and subtracting the polynomials, are the only two new skills that we are adding today. Being able to add and subtract polynomials. So go ahead and work on this first practice problem for just a couple minutes. I need to see this before we get started on the big ideas review. So take just a couple minutes to work on this. And then I've got one more example, and then of course one more practice problem at the end. And then we'll have some time for it. And you can use whatever, I mean, if you like the vertical method that I showed, lining them up like that, then you can use that method. If you like the horizontal, like I did in that example, then use that method. Adding 7x squared minus x, so we line up our like terms. So we line up the 7x squared with the x squared minus x with x, and then we don't have any numbers, so we are going to put them. So just 3 negative 2. So and then you gotta bring that line sign down. This 2. Bring this whole thing down. So it's always been a negative 2. You have to just keep that. So you can see I set up this revision sign, but this we're adding them together. That's what's in the middle. We're adding. Well, x squared plus 7x. So I get where you're coming from, but that would be if we were multiplying it. Okay? Since we're adding them, it's really a 1, right? So we have 1 plus 7. A and our x squared is x squared. Well, remember, the only time we can combine exponents is when we were multiplying, right? But we're adding them, so we can't combine the exponents. Okay, so the exponents stay the same. So we can combine the 8x. Michael brings up a good point when looking at these. We have x squared plus 7x squared. He said, why is this not 7x to the 4th or 8x to the 4th? The only time we combine exponents are with what we looked at in the last chapter, when we're multiplying numbers or dividing numbers. That's the only time we combine exponents. When we're adding and subtracting, then we're not combining the exponents at all. Okay. So that would not be 7x to the 4th. X squared plus 7x squared would just be 8x squared. Questions, Siobhan? No about this? It is about this. All right, what's your question? Oh. So here's a type of real-world problem that they would give you. It looks like a lot, but it's not bad. A penny is thrown straight downward from a height of 200 feet, so right up here. The penny is dropped. Super bad idea, but someone did it. At the very same time, a paintbrush falls from the height of 100 feet, so a paintbrush is dropped from there. The polynomials represent the height in feet of the object after t seconds. So our variable is t, and that's just saying after a certain amount of seconds, this is how quickly either the penny or the paintbrush would fall. Part A says, write a polynomial that represents the distance between the penny and the paintbrush after t seconds. So we want to find the distance between the penny and the brush. So all we would need to do to set up that polynomial is just subtract those two, the trinomial and the binomial that they give us. So the rate at which the penny is dropping minus the rate at which the brush is dropping. That would give us the distance between, right? Just like if I said that the penny was up at 200 feet and that the paintbrush was at 50 feet, and I want to find the distance between them, you would just subtract them, right? So it's the same idea, but just we're working with longer polynomials now, working with rate. Still confused? So we want to find the distance between the penny, which is dropping way up here, and the brush, okay? Just like if I gave you straight up regular numbers, you would just subtract the two heights, right? If I said the penny was at 200 feet in the air, you guys good or what? Okay. Just like if I said the penny was at 200 feet in the air, and the brush was at 50 feet in the air, and I said what's the distance between them? You do 200 minus 50, right? In this case, we're talking about the rate at which they're dropping, so it's continually changing, right? They're dropping and the heights are changing since they're in motion. You with me? So that's why we have the t squared and the t's and all that kind of stuff. But the idea is we're just subtracting two heights. So part B says, that's our setup. Part B says, what is the distance between the object after 2 seconds? So they're saying now our time is equal to 2. So probably what we would want to do before plugging 2 in for each one of these t's is what? What do we want to do before we plug that in?
Have an equation.
What?
Have an equation to plug it in.
Well, we have this equation up here in part A. We wrote an equation. Yeah, yeah, we definitely want to simplify because otherwise I'm plugging 2 in for 1, 2, 3 variables and I have this super long equation to simplify. But it'd be a little bit easier if we can cross some things out first. So if we were to simplify this equation, we have the negative sign in the middle, right? So we need to distribute that so we can drop our parentheses. So we have negative 16 t squared minus 40t plus 200. Now if I distribute that negative plus 16t squared minus 100. I just distributed that negative into that second polynomial. Now if we look to combine like terms, by t squareds, I have negative t squared, or negative 16t squared and a positive 16t squared. So they would just cancel each other out. Now I don't have anything that has to do with t. I don't have any other terms with t besides negative 40 t. So I finish there, and now I have 200, positive 200 minus 100. So that would leave me with a positive 100. Now that is a lot easier to plug t into than our equation of part A, correct? Yeah, that's a lot better. So now if I want to find the distance between the object after they're falling for 2 seconds, I can plug 2 in for t. Now I get that the distance between those two objects after they're falling for 2 seconds would be 20 feet. So that's a little bit longer of a problem, but that's the type of application that they would give you that deals with adding and subtracting the polynomials. Do we have questions on that? What? So here is the practice problem from earlier,
Oh, never mind.
from the first time. So if you got that done, you're all good. Here's one that I'm adding to it. So I need to see all 3 of these problems done before you start on the big idea of practice. Good? Maya, are you texting Michael about what he's supposed to do for the big ideas?
No, that's not.
Oh, that's fair. See? That's okay. But you just gotta let me know.
Okay.
I have a text from.
If you have a legit reason that you need to communicate with a parent, yeah, you can definitely text people. But just let me know before. Good for you. All right, let's go. Get to work. There are 19 or 20 questions on the big ideas. So, is it 19? So get these done, show them to me, then get started on the practice.